So, is this a problem? Yeah, it is. Hey, good morning, good afternoon, and good evening, no matter where you're at. Thank you for clicking on this video today. My name is Matthew Bonnig. In this video, I'm going to be talking about CDK, the bad parts. Now, if you know me, you know that I'm actually a big proponent of the CDK, but that doesn't mean that it's perfect. So I wanted to cover some of the sort of rougher edges of the CDK and really try to highlight how you might be able to soften those edges and continue to work with it and maybe not feel any of the pain. I'm going to go over 5 main points as I saw it. Now, I found these things in blog posts, articles online, comments made in the cdk.dev Slack server, and other places where I've just heard sort of people say, but this is why I don't want to use the CDK. So we'll look at each of those points. I'll review what they are and at least what I think the problem is with them, and then try to offer some solutions on how to work around these problems. Now, one thing is this is entirely my opinion. Like, you can agree with me or disagree with me. That's fine. In fact, I'd really like it if you did disagree with me to put a comment below. Reach out to me either on Twitter or at the cdk.dev Slack server. I love talking about tech, about software. There's very rarely ever one right answer to anything, so I just kind of like debating those things. And that's kind of why I wanted to put together this video anyway, because I think some of these things are kind of debatable, and I just wanted to offer my side of them. I've been working with the CDK for years now, and some of these things are problems that I certainly do see, but I think there are some ways to work around some of those problems. So let's start off with an easy one. This one is semantic versioning. Now, back in CDK v1, this was actually a little bit bigger of a problem. With v2, the semantic versioning problem isn't really as much of an issue. So what exactly is semantic versioning? Semantic versioning is when the version of a library or an application and the numbers within that version have meaning to what they represent. A semantic versioning scheme helps developers and helps users understand when a change in the system is going to either cause breaking changes or not. Now, there's only been 2 major releases of the CDK, V1 and V2. In V1, this was, the very first release. There were a lot of changes that were happening within the API for various modules, and some of those things did break. And even though only the minor version was incrementing during these changes, there were some breaking changes in the API, and this actually goes against semantic versioning. So in V2, what they did was they said, we're going to go ahead and take anything that doesn't have a stable API and put that in an alpha module. Alpha modules are those that are still sort of in development and that don't have necessarily a stable API. If you want to use them, you certainly can, but understand that as you use newer and newer versions of those alpha modules and constructs, that you may have some breaking changes and you may have to go back and change some code. But once those things get stable and they get introduced into the main library, the AWS CDK library, they should be pretty stable and they shouldn't be breaking much anymore. Sometimes it still does happen, but very rarely now. So one of the ways that you can kind of protect yourself from the semantic versioning changes and, breaking changes happening even within minor version numbers is really just snapshot testing and unit testing your code. One of the easiest ways you can do this is just create this snapshot test around all of the stacks that you create within your CDK app. If you go and you upgrade to a newer version of the CDK, and there happens to be a change in there, the snapshot test will fail immediately, telling you that either a new property has been introduced or a property has changed when you didn't really realize it. And it'll give you that quick indication that something may be going on there. You find it out during unit testing rather than during a deployment, and that's a very good thing, because during a deployment you may find out that may be too late to really handle certain changes that could come in. There have been 1 or 2 cases over the year and a half, 2 years or so now, where a minor version change has actually caused something as drastic as a bucket being recreated or other sort of stateful resources being created. So put snapshot testing around your code, and then anytime you do a minor version change, then you will immediately know, was there anything really changing on the CloudFormation side? And if nothing changes on the CloudFormation side, then you don't really have a breaking change. All right, moving along to the next one. This is that the CDK is AWS only. And that is true. The AWS CDK is a project that really only targets the AWS environment. However, the CDK for Terraform has been taking off over the course of the last year and has become more and more popular. It's a fantastic product. It allows you to create Terraform modules in code using constructs just like the AWS CDK. There are different projects that allow you to actually leverage your AWS CD code and just use the Terraform as the provisioning service and provider, and that's fantastic and can get you some really cool functionality that way. But then you've also got custom resources, and that is sort of your out for being able to create anything in any environment, any cloud, any software as a service. You just have to write a Lambda to do it. And then the custom resource will kind of handle the state management side of that a little bit for you. But again, the CDK for Terraform is great, and we see other projects like this coming up all the time. All right, so let's get into a little bit more, opinionated territory here. So one of the complaints I've heard a lot of times about the CDK is that when you were writing code with the AWS CDK, when you're writing TypeScript or JavaScript or any of those languages, that you could write non-deterministic code. And that's true. You absolutely can. However, you can also write deterministic code very easily. Most people, I tell them the only way that you're going to probably write non-deterministic code is if you go and try to make things like API calls to get information that then feeds into your AWS CDK constructs. Determinism is a great thing. Determinism can really help us make sure that every single time we run our synthesize routine and every time we apply a change set, that we get exactly the results we expect to get. However, it's not necessarily a requirement, in my opinion. There have been a couple of cases so far where I've written projects that go off and do make these API calls that go to some sort of external system and get data and then hand that over to the CDK, because that's really, really powerful. Imagine something like an onboarding system for users within your organization. So you have maybe a AWS account that everybody should have an IAM user in. So you want to create these IAM users in a very succinct and routine way. So you call off to some sort of central onboarding system, whether that be G Suite or Salesforce or an HR system or whatever it is that gets you your list of who should have access to an AWS account. And that API call comes back, and then you hand that over into your CDK code, and it generates out a bunch of constructs that represent those users, maybe even goes steps further and creates a really cool automation that goes and maybe emails credentials to those new people once the IAM user is created. That's really, really powerful, but it's not deterministic. If that API call came back with data that was either unexpected or unknown, you can't determine that every time you run that routine, you're going to get the same sort of thing. And that can be very scary, especially when you're talking about stateful resources or things that you don't want to accidentally get rid of and maybe lose some data along the way. An S3 bucket would be generally safe because they often have a retain policy on those buckets. But like an RDS database, that might be a little sketchier. You don't necessarily want to accidentally get rid of that because that API call either came back with empty data for some reason or failed or came back with unexpected data or things like that. Now, there are ways you can get around this. You can kind of get the best of both worlds. The pattern that I've gotten into, something that Thorsten Huger and I talked about at one point, and after he convinced me on this, I've been using this pattern going forward on pretty much most of my projects, where I will write a little npm run script that makes the API call, takes that data that it gets, and just dumps it to a JSON file that's in my project. And then my AWS CDK code just reads that JSON file and runs with that, so that there is that break between the API call and the CDK code. And what this does is it means that all of the input to my CDK code is clearly available then within the repository. That JSON file gets committed to the repository. It can get code reviewed like everything else, and it is still the main driver for everything else that goes on in the CDK code. And that way you can still get sort of this dynamic capabilities of making API calls, but you get the safety of more deterministic code. So we still get a lot of really dynamic capabilities without losing true determinism. So there are ways about it. You just want to be careful about how you do that. Now, this pattern I mentioned is basically how context works. If you've ever worked with a VPC construct, or if you've ever done a from lookup on anything, then this is how context does it. It makes an API call, it takes those results, it stores it in context. Your cdk.context.json file is supposed to be committed to your repository, and this keeps your code deterministic and also kind of makes it work a little bit better because every time you synthesize, it doesn't have to go off to your AWS account and make API calls. So we're kind of replicating that with the pattern that we've determined. The I would love to use context actually for this. It would be really great, but unfortunately, the context API isn't really easy to work with when it comes to the average user writing CDK code. If you're going to be creating L2 constructs or even L3 constructs, there are ways to tie into it, but it's not incredibly well documented. It's not particularly easy to use. There are actually some RFCs and PRs and things like that open in the GitHub repo. I'll go ahead and include a link to them here or in the description. And you can go take a look and see what they're talking about potentially doing. And if that stuff starts to come into the CDK, maybe V3 or sometime in the future, then that would probably be the path forward, is just go ahead and continue to leverage context in the same way that L2 constructs like the VPC construct do. So hopefully that kind of nails down a little bit of the deterministic question. If you think that I haven't nailed down a good definition of it, or if you've got any comments or anything, like I said, leave a comment below, reach out to me on Twitter or in the cdk.dev. This is one of those kind of fun problems to me because determinism in software is a very strictly defined thing, but it always means a little bit something different to everybody. Your inputs, meaning resulting in the same outputs. Well, what exactly is an input into your system? You could probably argue that the results of an API call are your inputs, and they would be. But if you can't clearly see what those inputs are and you don't know exactly what those inputs are, then are you really deterministic? Probably not. So, all right, so moving on, let's talk about imperative versus declarative. So one of the things that a lot of people, including me, the first time I actually saw the CDK, I was introduced to it by Eric Johnson. And the first thing I thought of is I like my statically typed code. I like things being written out in a static language, and I don't really see much of a reason to have imperative languages like TypeScript or Java or anything like that to define my infrastructure. So imperative languages, you provide an order of operations. You say declare this variable, then do this function call, then do this operation like adding two variables together, then do this, then do that. That's your imperative languages. That's TypeScript, that's Python, that's most general purpose languages that you would write an application in are typically imperative. Declarative languages like JSON, YAML, CloudFormation, HCL, these are languages in which order doesn't really supposed to matter. It's really just you're declaring these are the things and you declare the relationships between them, but it's usually up to some other system like Terraform's providers or CloudFormation or whatever to parse that and sort of understand how and what to do with things. Think in the case of like a CloudFormation file, you can put your resources in any order you want to within that file. It doesn't really matter because you are just declaring these are the things that I want, and it can determine, what kind of is important to create first later on within the process. But as far as what you define in the language, order doesn't really matter. However, that's not really the case for imperative languages like TypeScript. Order matters. If you want to use a variable, you have to declare it above the place that you use it. You can't declare it below the place that you use it. You can do this all you want in CloudFormation and HCL and other things, but you can't do it in imperative languages. So is this just personal preference? Well, mostly, I think. I personally have come around on the imperative languages for defining infrastructure, and I'll explain why. I came across an issue a while back with Mergify. If you're not familiar with Mergify, it is a great little system for taking pull requests that you have in a Git repository and automatically performing operations on them based on a set of rules that you define. So the Mergify configuration is a static declared file. It's a YAML file that you typically put within your repository. And you say, well, if we have this many approvers, go ahead and automatically merge it in. So people can approve your PR, but they don't necessarily have to hit that merge button right away. People can just kind of approve and the merge happens automatically. Really cool feature and very, very helpful. Mine wasn't working and I wasn't really sure why. Now, in the case of Mergify, they actually provide within the UI for Mergify within, in this case, GitHub, a nice little breakdown of how all the various rules are working and if certain conditions are being met and if they're not, and where some of the implicit definitions are coming in. So, for example, I may have it set up on my GitHub repo that I have to have at least two approvers before anything can be merged. Mergify can't override that, and you don't have to declare that specifically within your Mergify file, but that's still a requirement. So for me in this case, I had one approver, but the repo was saying that you still have to have two. And so that's why it wasn't able to go through. So this was a really handy case where Mergify was really good about telling me, here's why your declarations, your declarative file, and the rules that you have set up aren't really working the way that you expect them to. But that's something that has to be built by the tooling around it. It doesn't just come inherently within the language you're using, whether it be YAML or JSON or anything else. Take, for example, a CloudFormation file. Let's say you have a conditional in your CloudFormation file, or you've got a lot of intrinsic functions that you are using, like joins and things like that. Understanding when or where that stuff might be failing is actually really hard to do. If you've written out of this big complex conditional statement or these big joins and things aren't quite working, you may not get a lot of information as to why they aren't. You can't just attach a debugger to CloudFormation and say, what do you think is this conditional value? What is the runtime value of this conditional that you're seeing? And therefore, why am I maybe not getting the resource created that I thought I should? And that's really where I sort of started to lose my love for declarative languages and realize some of the power with some of the imperative stuff is when I'm going through and I'm creating some CDK code that maybe has some complex logic into it. Maybe there is some value that I'm creating within my construct that is a concatenation of multiple different things. Maybe it's just a simple string value. And being able to attach a debugger to my code and being able to go through and see exactly how my TypeScript is putting together that variable is very, very powerful. Understanding if we have some complex logic around conditionals and if statements or for loops or things like that, being able to step through my code and being able to understand exactly what is going on helps tremendously in creating the right thing up front. One of my first experiences as a DevOps engineer a few years ago was I was tasked to write a Terraform module for a Magento application, a very generic Magento architecture within AWS, and I also had to do it for Azure. And it took me probably about a month and a half, almost 2 months to create these things because the only way that I could really test to see if things were working the way that I expected them to was to actually execute that Terraform module, to actually have it run against an environment and then go check that environment to make sure that things were working correctly. Now, I can do a plan, and a plan in Terraform will tell me a lot about what is going on, but it won't tell me everything. So I ultimately still had to get these things deployed out into an environment, and then still had to run through end-to-end testing on that environment to make sure that everything was working the way that it was supposed to. And if it turned out that some key value that I was passing from one resource to another wasn't quite right, it was very hard to figure out necessarily, okay, what did I do wrong with my HCL code? How did I not reference this variable correctly? Why is this thing showing up either blank or undefined or a default value? And it was very frustrating to go through and work through all this. And when I came across a situation where I had to manage about 210, I think 230 or so RDS instances, I knew that there was no way I was going to be doing it with static files. I wanted to take the definitions of these RDS instances and their instance type and their size and these other things that were important and boil that down into a very, very simple file. And that was just a JSON file. And then just give that to my CDK code, and it would render out what ended up being, thousands of lines of CloudFormation files for subnet groups and the RDS instance definitions and all those other things that have to be done. And I think that if I had tried to do this with just standard CloudFormation and some templates and other things, it would have taken me significantly longer to actually develop those things and get them done. So that's kind of where I've come on this declarative versus imperative. I don't necessarily think that declarative is bad. I just think that a lot of times it can be difficult to work with, especially when you're talking about really complex definitions. And that's why I've kind of come around to the imperative side and say, for me personally, this is where I'll be going in the future. This is what I really like. That debugging capability is really powerful, and I'm not beholden to the system that I'm dealing with and what they make available. CloudFormation, for example, you have intrinsic functions that you can run within your CloudFormation, but there really aren't a lot of them in there. They syntactically can be a little confusing sometimes, and it's not something that's getting expanded a lot. Over on the step function side, we have sort of a similar issue around ASL and the functions that are inherently built in and intrinsic functions you can run within your state machine. And they just added, I think a week or two ago, a whole new slew of things for the first time in I think a year or a year and a half almost, maybe even longer. And that's a really slow time frame. That is the nature of DSLs and the nature of these systems, that it's a custom built language at the end of the day. And if the features of that language haven't been built by the developers, there's almost no way of doing it yourself. And then you are handcuffed by what you can do with the system. And that's just something we don't generally see with a general purpose language, because these things have been fleshed out for years, have every possible thing you want, and have a good extension system in them, so that if you aren't getting the thing that you want directly, you can probably just import a module to get it done. So I'd really like to hear your thoughts on imperative versus declarative. If you still think declarative is better, I'd love to hear why. So again, as always, comment below or hit me up on Twitter. All right, so the last one, and this is kind of the big elephant in the room. I saved this for last because I think this is probably the one that is maybe the most well-known problem with the CDK, which is that it pushes the ownership of these very powerful abstractions onto the users of those abstractions. So what do I mean exactly by that? Well, let's take a look at, for example, the VPC construct. This is a kind of an L2, but really more of an L3 construct within the CDK. If you've been using the CDK at all for any time, you've probably used this thing multiple times. Very good, useful construct. When you go and you create this, you can sit there and say, well, I want these subnets, and I want this NAT gateway, or I want multiple NAT gateways and other things. Well, abstractions are supposed to not leak the underlying implementation. At least good abstractions don't leak that underlying implementation. But because of the nature of the CDK, it has to. You can't really hide it, because what you are owning as a user of the CDK is you're owning your code that defined that VPC construct. But then you synthesize it into CloudFormation, and now you have a CloudFormation file that has potentially dozens of resources in them. And that is still within your ownership. That is still within your sphere of control. And you are still responsible for all those things when you give it to the CloudFormation service and say, go provision all of this. So, that is kind of the crux of the problem, is that These are abstractions. They are logical abstractions, but they're not really physical abstractions. You still have to own those underlying implementation details at the end of the day. If something goes wrong on that CloudFormation side, let's say you have a couple of resources that aren't referencing each other correctly or aren't lined up correctly, and that CloudFormation stack change set fails, you own getting that thing solved. That's completely on you. You're going to have probably a little bit of a hard time trying to open up a support ticket to the CDK team and saying, hey, what's going on here, unless it's kind of legitimately their problem. But that's probably an issue on the GitHub board, and they've already found it by the time you run across it. But I digress. When you own that underlying implementation, that does cause you some headache long term. Now, I mentioned earlier about semantic versioning, and one of the ways you can kind of protect yourself from it is unit testing and snapshot testing your code. And when it comes to this ownership problem, that's also partly a solution to it, is making sure that when you write up all this CDK code, you test it so that if those underlying implementations or those constructs change in the future, that you know about it and you may be able to take some actions. For example, maybe you just don't upgrade to the latest version of the CDK, or perhaps you go and start to come up with a plan for replacing the code or migrating to this new construct or whatever it may be that's causing you issues. Now, again, we haven't really seen this happen a lot in the CDK, but it's possible, and it has occurred a few times before in the past where construct changes really resulted in a lot of pain from users. Good example that has come up recently. The Lambda Node.js runtime 10 and 12 was deprecated recently within AWS. However, a lot of CDK constructs were using Lambda functions that were running on 10 and 12. So what a lot of people were getting emails about from AWS was saying, hey, here are all these Lambda functions that you sort of own, but sort of don't own. You own them because you have to own them, but you didn't write these things directly because they're abstracted underneath of an L2 or an L3 construct. Well, all those things are now running deprecated versions of the AWS or the Node.js runtime, and you now need to get those things updated to the latest versions. And if you were like me, the first question was like, I don't know where exactly these things were being created from, and I don't know exactly how to get them upgraded. And I'm someone who's used the AWS CDK pretty much every day in my career for the last 2.5 years. So this was a struggle. And the steps that we took internally was first identifying the functions, then trying to reverse engineer from just function names what stacks and what CDK apps they were related to, and then going into those CDK apps and either updating the versions directly if it was something that we controlled, or just updating to the latest version of the CDK if it wasn't. But sometimes those latest versions of the CDK presented other issues that we may have had to work around. So it wasn't a real simple and easy just hit a button and you're done type problem. And this is where the ownership comes in. So, is this a problem? Yeah, it is. Is it a problem that is worth it? I think so. Even though I just mentioned how I spent a lot of time kind of having to deal with this problem recently, I would still take that over top of not having the CDK to help me do what I do. If it wasn't for the fact that the CDK exists, I probably would have had to have built something similar to it anyway. This idea of building abstractions is nothing new. We see this happening all the time in all sorts of different areas of software development. React and front end UIs is probably one of the most common places where we see this. You go out to a third-party library in React and say, well, I want to bring in this component that gives me this really nice looking animated button. And that's cool. You bring this thing in, you drop it into your code, but what actually ends up getting rendered out onto your web page is still just raw HTML, still some JavaScript, and that's still something that you kind of have to own. But I don't think anybody would doubt that React has been a very valuable product within the UI development framework area for the last 10 years or so. And I think we'd have a very different uh, problem right now if we didn't have those types of frameworks and these types of abstractions. But unfortunately, this is kind of where we're at with our infrastructure as code as it is right now. And I would still take this problem over not having the CDK. And on top of that, I actually sort of prefer having the ownership fall on me as the user, because I then have more control over what is getting built, what is getting deployed. I can move quicker, I can adjust quicker to requirements than if I was dependent on an AWS owned front to back resource. One thing, I had a really great conversation at reInvent 2021 with Ben Kehoe, who is probably the one of the, I think, biggest opponents to the CDK that I've met. And we chatted about things, and we kind of, I was really trying to understand more of like really what was the crux of his issue. And one of the things that we kind of discussed was, well, what would happen if we could take these L2 and these L3 definitions and turn them into legitimate CloudFormation resources, either through third party registries or through something that AWS themselves provided. So we can see similar things on the SAM framework. The Serverless Application Model Framework is a CloudFormation based tool that allows you to define your resources in a simplified syntax from what the CloudFormation Lambda function, API gateway, DynamoDB table type resources are. So traditionally, you would go in and you define this API gateway, and API gateways in CloudFormation are verbose to define. They are not very simple. And one thing that SAM does really well is it boils down that definition into something much more succinct, much more easy to write and to understand exactly what it is and what it's trying to do. Behind the scenes, a macro and work on the CloudFormation side and owned by AWS then turns that definition into the actual underlying resources. And that's really nice because as a developer, I never really unveil that abstraction, then that unveiling, that leaking of the underlying implementation never really happens in SAM like it does in the CDK. So that's an approach that is very valuable. But if you take a look at SAM, there hasn't been a lot of movement in SAM over the course of the last year and a half to really introduce a lot of different types of resources. SAM is very much focused on building serverless based applications. So API gateways with Lambdas, DynamoDBs, maybe some event bridge stuff, maybe some SQS, SNS, those types of things. But that's not the type of AWS infrastructure that I create on a regular basis. Unfortunately, I find myself stuck in a lot of more traditional style applications where we have a containerized application running in either ECS or EKS. We have an RDS instance, we have EC2 instances in some cases, and application load balancers. And these are things that don't have representations within SAM. So I can't use SAM to build those things. I mean, technically I can, but I'm just writing raw CloudFormation at that point. So if we had taken the same approach and if we had done the similar sort of thing with the CDK, that would be great, but only if you could keep that velocity and you could keep the speed that we've seen out of the CDK. The CDK has been releasing about once a week for pretty much nonstop for the last 2 years or so. They've had a very good weekly cadence. Now, not every release is packed with features, not every release is packed with bug fixes, but the marker keeps moving forward, and it's something that we don't really see a lot in a lot of AWS services right now. I would say potentially some of the only ones are over on the data analytics side. We're seeing a lot of feature development happening over there, and we're seeing some stuff happening within step functions, which is fantastic. I absolutely love that service. I'm glad to see that they are continuing to improve that thing over and over the course of the last 2 years. But CloudFormation is extremely stale right now. It is a system that has really not changed much in the last 2 or 3 years. And if that's the type of velocity that we were going to get, if this had been something that had performed like SAM and had been like SAM, where We create these CloudFormation resources that are simplified representations, these L2s and L3s just being CloudFormation resources that are macroed into the complexity underneath of it. If we saw this the standard velocity, that would be a big problem. It's something that couldn't be adopted. They wouldn't be able to get out all the features. But by making this a case where these L2s and L3s are things that are developed by the community. I've created a bunch of constructs before in the past, both internally at our company as well as publicly available. Um, you know, we would be in a very different spot. And I think that ultimately it has been a positive thing for the AWS community having the CDK. And yes, it has caused a pain, and there should be better support. There should be better thought put into lessening the pain of that customer ownership for those situations where it goes bad. But the benefits from it, in my opinion, far outweigh those pains. So, yeah, that's what I think about the customer ownership problem. So, that's it. All five things that kind of identified the semantic versioning, the determinism, the CDK being sort of AWS only, not really. The imperative versus declarative, and why I think imperative is actually better in the long run. And then finally, this issue of customer ownership. So, again, if you disagree with anything, I would love to chat with you about it. I'd love to kind of talk about the finer points that can't just happen in a one-way conversation like this. So hit me up on Twitter. Hit me up on the cdk.dev Slack server, or just leave a comment below here in the video, and I'll be glad to respond to you then. So thank you again for watching. Hopefully you got something out of this, and have a great day.